Welcome back to The Farmer Was Replaced. We're going to grab unlocks and start with watering unlock. The plants grow faster when they are watered. Soil and turf have a water level ranging from 0 to 1. So this is a lot of complicated text here. Tank can hold 0.25 water. So function get water returns the water level if the ground is over. Growth speed of a plant growing on tilled soil grows linearly from 1x speed to at water level 0 to 5x speed at water level 1. So from 0 to 1, if it's at water level 1, it grows 5 times as fast. Soil dries up over time. We need water tanks to do this. Tanks fill up automatically, so basically the more tanks we have, 100 empty tanks will have one water tank every 2 seconds. So it looks like the more empty tanks we have, the faster the fill rate is. For watering, I've done this function here, so I just added this water crop to the grow tree. We're just going to water the trees right now. So this defines the water crop, and this is my variable desired water level. I know it's probably not great to have such long variables, but I don't know, makes sense to me, so I'm going to go with it. So basically, if number of items.water.tank is equal to 0, we have to buy tanks. That means if we have no tanks, we got to buy some. And if the water level, so get water measures the water level of the tile here. If it's less than our desired water level, which is up here 0.5, use the item water.tank. Now for some reason we don't have a water tank. I think it'll just try to do it anyway and then keep on moving. So buy tank down here basically just does a while loop. So while number of items empty tanks is less than 100. I don't like hard coding numbers like this, but I didn't know how to get around it. So while we have less than 100 empty tanks, trade empty tanks. If the number of items of wood is less than 5, because that's what it costs to trade. Let's see if we can get it on the screen here. It costs 5 wood to trade for a water tank. So it's going to do this till it hits 100 tanks. But if it finds that we have less than 5 wood, we can't buy a tank, so we're going to break out of this loop. So I think that'll work. I know it's not super efficient, but let's give it a go and see what happens. So spending all my lumber, buying tanks. It's going to get down to 5 and break out. Defined water level has never been defined. Must assign a value to a variable before using it. Desired water level. It's right here. Did I spell it wrong? Looks like I've defined it. Oh, it's because it's defined outside of this, maybe. Yeah. I think it's because it's just defined outside of this function, so let's try copying this or moving this inside the function. I think that should work. Let's try that. Yeah, so that was it. So it's growing trees now because it's sensing it doesn't have 400. Looks like it's watering them. Yeah, it's definitely watering because we're losing our water. It looks like we're spending water faster than we're producing it. But I think it'll level out once we start. Maybe not. We might have to increase the amount of water tanks we have. So one thing I noticed is it's watering every tile, even if there's not a tree on it. So that's super wasteful. We should probably move this water crop out of here. Let's move that out and put it over here so if it plants a tree, it should water the tree. That way if it doesn't plant the tree, it's not going to water the tree. It's because it's under this if statement. So that should save us some water. See if we start accumulating water now. Looks like it's keeping up at this point now, so we're not wasting the water. It's only watering it if we plant a tree, so that seems to have worked. You can kind of tell by the color of these things that this is water and this is not. So our water level is staying pretty consistent. We might want to consider moving the tanks outside of this loop because it is not climbing in water tanks and water is slowly climbing. We'll leave it like that for now. Let's take a look at the unlock menu. Let's upgrade the carrots. Costs 300 wood. And let's upgrade the trees and bushes. 300 hay. This will cost 480 lumber, so we'll have to up our numbers. Same with that, so let's check our... Let's leave trees and hay at 500. Go ahead and run this. That's going to run our numbers back up to 500. This needs to probably upgrade these one more time as well, just so that it makes it faster. And I think we'll do pumpkins next. We need 1,000 carrots for that. So we're going to have to up our carrot limit to 1,000 as well. But that's why I want to upgrade these so that we can get to 1,000 carrots easier. So I also noticed my tree code here is harvesting every tile. And even though it's only planting every other tile, so that way, since this was grass, hay's actually growing here. Kind of an unintended consequence of my code. But I'm going to leave it like that because I don't mind it. We'll just have extra hay. Again, not super efficient, but it'll work. So you can see it's planting trees and harvesting hay every... So we'll just have a boatload of extra hay. If it becomes a problem, we'll look at changing the code, but right now it's just going to do it till we hit 500. We hit those numbers pretty quickly, so let's go ahead and hit carrots. Do the trees as well. I forgot we gotta change what is the next unlock for carrots. 1,000 trees. We'll see how long it takes to... Like, hay's already there. So now it's gonna plant all the lumber, which is gonna harvest extra hay because of the way it's set up. So I notice it's trying to plant the trees twice, so if it gets to a tree and it's not fully grown yet, it tries to plant on top of it anyway because it's not checking to see if it's already a tree. So I got this line of code here, if getting any type is already a tree, does not equal a tree, I should say. Plant one. Otherwise it'll just skip the plant command. So that way it'll check to see if it's not a tree. If it's not a tree, it'll plant a tree, and then it'll water it. So hopefully that'll speed it up. Can't tell, it looks like it's skipping trees that aren't fully grown. It's not trying to plant them, but anyways, let's go to unlocks. Let's do sunflowers next. I'll read that in a second. Speed upgrade, we could do this one too. And grass upgrade, we can go ahead and do this one. Expand, we can't do without the pumpkins. Carrots, we can upgrade those as well. And trees, we can upgrade those in a second. There we go. So we got lots of upgrades done. Let me read the sunflower thing and then we'll come up with a plan. Sunflowers grow with a random number of petals. We have to harvest the sunflower with the most petals on it, and it'll give us the power of the whole farm. If we harvest one that has the max petals, it'll destroy all the plants on the farm. So we have to somehow keep track of which has the most petals and harvest that one. The other difference is right now we've been planting this one, moving up here, and then deciding what to plant here based on how much inventory we have. That's not going to work for the sunflowers. We're going to make sure that once we plant a sunflower, we plant the whole field in sunflowers so that we can get the maximum amount of power, because how much power you receive from harvesting a sunflower is based on how many plants are on the farm. It's the square root of how many plants are on the farm. So we'll have to plant there's a new command called measure. We can measure it right away, see how many petals are on it, and we'll have to make sure that we've measured all of them, and then figure out which one has the most and harvest that one. We're going to unlock this multi-trade option. This basically allows you to buy multiple items at once, so you're not trading constantly. So we can, so basically at the start of our sunflower code, we can trade enough seeds to plant the whole field instead of doing it individually. First thing I want to do is write a function that allows me to move to a certain location. So that's my attempt at this. I'm not sure that using a while loop is a good thing, but why not? So this is defining the go-to function xy. You can pass it an x and a y, and it'll attempt to go to that location. So this is basically why get position x minus x, which is the passed in x here, is greater than 0. So basically if you're here, your x is 2 minus, say you're trying to get to this location here, this would be 0. So 2 minus 0 is 2. So 2 is greater than 0. You want to move west. So it'll move there, and it'll keep doing that, I'm assuming, until it gets to here, and this will be 0. So it'll just exit out of this one. This one's basically the same thing. This would be 2 minus 3 would be -1. So -1 is less than 0. So it would move east. And same thing on the y position. So I don't know if this is going to work, but we're going to try it. It does appear to work. 4, 1. Alright, so there we're stuck in an infinite loop. Why are we stuck in an infinite loop? Because 4, 1 does not exist. That's why. So that's a little bit of a problem there. We'll have to see if we can check to make sure the location actually exists. 1, 3. So that's not right either, right? 1, 3 would be 1, 1, 2, 3. It should be up here. Why is that not working? This is 0, 1, 2, 3. 3 should be way up here. Why is that not working? Oh, because this is greater than and greater than, so we got to do, this should be less than. There you go. So 1, 1. Do 2, 3. So that's actually 3, 2. So 1, 3, 1, 2. So yeah, it is working. I just have to figure out how to make sure that we do a check somewhere to make sure that the coordinate actually exists. I threw this in there if x is greater than the world size minus 1. So world size is 4, but since this starts at 0, this would have to be 3. So 4 minus 1 would be 3. So if my x coordinate is larger than the world size, or the y coordinate is larger than the world size, just return. So it's not going to go to that location, it's just going to return out of it. So it doesn't get stuck in the forever loop trying to find that location. I'm not sure it's needed because we should never pass in a coordinate that is not in existence, but I guess it's just a safety check. Let's try it real quick. Let's do 4, 2, and it just doesn't do anything, so that does work. I had to learn a lot of new stuff for this one, so I'll be shocked if this works. But so this is my attempt at it. Grow sunflowers. We're just defining this function here. So I have 3 variables. Max petals started out at 0. Max x location starts out at 0, and max y location starts at 0. So this is the location of the petal that has the maximum amount of petals. So the first thing we do is trade our sunflower seeds. It costs 1 carat. And we unlock the multi-trade. So this is get world size times get world size. So it'll times 4 by 4, which would be 16, so it'll trade for 16 sunflower seeds. Now I'm not checking to see if I have enough wood because I'm going to put this below this, so if it gets down to here, we'll have 1,500 carats, so it should be, and the world size is never going to be larger than 1,500, so And then I just call clear. That's a new command that just clears the field. So then this for loop is the first time I've ever done this. But basically it says for x in range, for y in range. So for y in range, get world size. So world size is 4. So it's going to say for y in range 4. Basically it just means it's going to do this code 4 times. So it's going to do it once, increment y to the next one, do it again until it hits the world size. So this would be plant entity sunflower, so we'll just plant a sunflower. And then if the measurement of the petals is greater than or equal to the max petals, which is 0 right now, it's going to, this is not going to work. We're assigning this right away, which is not the case. Yeah, okay, this is right. So if measure is greater than the max petals, go ahead and assign the max petals to the measure, and then store the x location and store the y location, and then move north. It's going to do that 4 times because that's the world size, and then it's going to exit this for loop here and move east, but then we're still inside this 4x for loop. So it'll do the move east, and then it'll do this again for the next one, and then it'll move east, so it'll do this 4 times. So it should evaluate the whole field. At the end, we're going to go to the max location. Now I have it stored greater than or equal to because if it plants the last one and it's equal to the max petals, we might as well just stay there. So that's why it's equals to. Otherwise you could just do greater than. So go to max x location, go to max y location. That's the function we just went over. And then this is to basically check y get entity type equals sunflower. So that means why this is a sunflower. If it can harvest it, harvest it. So that basically means if it planted it right away and it's already at the max petals, it can keep checking if it can harvest it until it harvests it, and then it'll no longer be a sunflower. So I think this should work. At the end here, we'll have to reset our max petals back to 0. I'm not too worried about resetting the x and the y location because it's going to reset itself in here, but we need to make sure max petals gets reset to 0. So let's do max petals equals 0. So I don't know. I'm going to run it. I'm just going to leave it over here for now. We'll just call it from here, so that way we can test it. Grow sunflowers. And I don't know, let's give it a go. So the first one was the operator cannot be used on the operands none and 0. So let's figure that one out. None and 0. Oh, so you can't use measure. Operator cannot be used on operands none and 0. So I think what's happening here is it's trying to measure hay, which is making an error out. So I think we actually need to throw a till in here. That will till the land and then plant the sunflower, and that should make sure there's something to measure. So that works there. It went to that location and it harvested it. Perfect. And now we have 3.99 power. So cool. The other thing we could consider doing, since it only harvested one, we could actually go find the next one and harvest that one too, and do it 2 or 3 times to max out our efficiency. But that would require measuring the whole field again. I think once we create a list, we can add, lists are way down in here though. Once we unlock that, maybe we can make a max petal list and add it to that, and then we can go to those locations and harvest those. So for right now, I'm going to leave this as is until we get the list going, and then I will, because otherwise we'd have to remeasure the whole field, and it'd be just, I don't know, probably not worth it. So let's just throw this elif statement in the main code here. And then again, that way I'll make sure we already have 15 counted carrots, so we won't have to worry about how many carrots we have when we get to this point. If I just do less than 5 right now, I guess we will see how much power we need. This needs indented. So we only have one power right now. I don't know how fast we use power. Let's go ahead and try this code and see if it works. So it's definitely burning through power pretty quickly. But it does appear to be working. So let's go ahead and do some unlocks. I think with the power being down here, it's going to be a little bit troublesome because it's going to do all this stuff before it gets to this. So we're going to run out of power before it even gets to this. But so I'll think about that in between episodes and see if I can figure out a way to make sure we always have power. But let's go ahead and hit play. And then let's go ahead and do grass upgrade, speed upgrade. Can't do that. We can unlock carrots, better. We can unlock trees, better trees. Now we can. And sunflowers, we have to wait till we get the mazes done. So he's gonna harvest hay. See, we're already out of power, and he's got to go through all this before he can get to power. So I don't know. I'll think about that in between episodes. So that's gonna do it for this one. Thanks for watching. We'll see you next time.